A body is said to be in equilibrium if no net force acting on it. For example, if the book is lying on a table, so this is also considered that this book is in the state of equilibrium because the weight of the book is acting in the downward direction and the weight of this book is balanced by the upward reaction which is produced by our table on the book. In this way, the forces which are acting on the book are equal and opposite, and these forces will cancel the effect of each other, and in this way no net force will act on a body, and we can see that this body is in the state of equilibrium. And if the log of weight is balanced by the two forces F1 and F2 which are acting in the upward direction, and the weight of this log is acting in the downward direction. So these forces are equal and opposite. These forces will cancel the effect of each other. So we can say that no net force acting on it, and this log is also in the state of equilibrium. And if the car is moving with the uniform velocity, and if the aeroplane is moving with the uniform velocity, so these are also the example of the bodies which are in the state of equilibrium. First condition of equilibrium. A body is said to be in equilibrium when the resultant of all the forces acting on the body is zero. For example, if on a body 1, 2, 3 and 4 forces are acting, and if we will add all the forces and take the resultant of all the forces, so if resultant of all the forces is equals to 0, so we can say that this is the first condition of equilibrium. So if 1, 2, 3 and more forces are acting on a body, so if we will take the resultant of all the forces, and if resultant of all the forces is equals to 0, so this is called the first condition of equilibrium. This is a Greek letter sigma which is used for the addition or summation. First condition of equilibrium in term of x and y component. So if f1x, f2x, f3x, fnx, so if we will take the resultant of all these forces, if it is equals to 0, so we can say that on x component resultant of all the forces is equals to 0. Y component f1y, f2y, f3y, fny. If we will take resultant of all the forces which are acting in the y direction equals to 0, so this is also called the first condition of equilibrium. Second condition of equilibrium. If on a body two forces are acting, F1 and F2, these two forces are equal in magnitude but opposite in direction. These forces are acting along the same line. So if we will take the resultant of all the forces, so the resultant of all these forces is equals to 0. So we can say that this is also called the first condition of equilibrium. But if we will change the location of these forces, so due to the change of the location of these forces, a turn is produced in the body. Now this body has the ability to rotate. So due to the production of the rotation, we can say that torque is produced in the body. So now we can say that the resultant, if the resultant torque acting on the body is equals to 0, so this is called the second condition of equilibrium. So a body is said to be in second condition of equilibrium if the resultant torque acting on the body is equals to 0.